Woo! Okay, so we're still doing implicit differentiation, and we're starting on another example, and we're going to say, given that x squared minus xy plus y squared is 9, and this question has a few parts to it. So the first part is we want to write the general expression for the slope of the curve. So write the general expression for the slope of the curve. When it says the slope of the curve, what does that mean? Derivative. So they want us to find the derivative. Does it look like the y is going to be easy to solve for? You got it in 2 spots. Yeah, probably not. So in that case, we're going to do implicit. Anytime you got y's in multiple spots, implicit is the way to go. So how do we find the derivative of that stuff? That should be a little bit easier now that we've done. Okay, so we're going to say 2x minus okay, so I've got the first times the derivative of the second plus the second times the derivative of the first. Should have given myself more space. All right, and then what do I have? Plus 2y dy dx equals 0. Marvelous.
Oh my god.
Okay, I'm going to simplify a little bit. Are you guys okay with me distributing this negative right now? So minus x dy dx minus y plus 2y dy dx equals 0. So what is our goal now? Yeah, get the dy dx all by itself. Okay. So which side do you guys want to leave the dy dx on? Should we move the dy dx's to the right or leave them on the left? Leave them? Okay, so if we're leaving them on the left, then that means I'm going to move the 2x. And I'm going to move the y. So what do I do now? Yeah, take out that GCF. And what's the GCF? The dy dx. And then we got negative x plus 2y. If you had a GCF of like let's say this was negative xy, and that was 2y still, would you have also taken out a y as a GCF? No, because it would not have helped you isolate the dy dx. Does that make sense? So we're not truly taking out a GCF, we're just saying kind of the same way of thinking, is that I got it in common so I can take it away from both of them. Okay. Just wanted to clarify since we keep calling it a GCF, and it kind of is, but it's kind of not. Okay. Now what do we do? Yeah, divide by that parenthesis. Right there, divide by it. Do you guys like how I got lazy and I didn't write what the parentheses were?
Oh, yeah.
Well, you can't, first of all, because this x has a plus with it. So you'd be saying plus and divide cancel out. So you can't do that. But you wouldn't do anything. You could just leave it. Okay. The second part that we're going to do, part B, is we are going to find the coordinates of the points on the curve. So find the coordinates of the points on the curve where the tangents are vertical. You had a good thought. You said, so there's 0. What is 0 for the tangents to be vertical?
X.
The tangent line is vertical. So tangent lines, right, the derivative tells us the slope of the line, right? The slope is not 0 though. Vertical tangent lines, what do we know? So horizontal tangent lines, the slope is 0. Vertical tangent lines, the slope is undefined. How do you make a slope undefined if you have a fraction? 0 on the bottom. Okay, so tangent lines are vertical means when you've got m equals a fraction that you got 0 on the bottom. So if we're going to find the x and the y coordinates where the vertical tangent line is happening, what do? We don't know if it is 0. We know that it's going to equal. Something's going to equal 0. Say it again. Set the bottom equal to 0, yeah. So we're going to take this bottom right up here. We're going to set it equal to 0. So this does not help us too much because we can't really solve for a variable. We can add the x to the other side and then say, cool, 2y equals x. That doesn't help me solve for either of them, but it's at least they're isolated, I guess. Now, if I had given you, let's say I told you the x was 5, and I wanted you to tell me what the y coordinate was, where would you plug that 5 in to find the y coordinate?
To the x.
To the x, right? In which equation? Would you plug it into the derivative, or would you plug it into the original problem? You would plug it into the original problem. Because if you plug a number into the derivative, what does the derivative tell you? The slope, the instantaneous rate of change. So if you want to know a y coordinate, you got to plug it into the original. Okay? So what we want is, we are talking about coordinates. We're trying to find some coordinates. We got to take this that we have right here. We got to go back and plug it into the original problem. Okay? So I'm going to go ahead and write out the original. I got x squared minus x times y. Oh, actually, I'll go ahead and write it. So you guys, when you're at like 9 minutes-ish is where you'll start watching it, okay? So x squared minus xy plus y squared equals 9. And what we are going to do is we are going to take every x that we can see and we're going to replace it with 2y. Hi. So I'm taking the x and I'm replacing it with 2y.
Send me a seat. Bye, mister.
Hi. So if you have 2y multiplied by 2y, what do you get? 4y squared. And then we got minus 2y squared. And then plus a y squared. Oh my gosh, my y's take up too much space. Can you guys see that okay? Is that confusing? The cheerleaders are so disruptive. All right, so we have 4 and -2 and +1. So how many y squareds is that? 3.
Have your attention, please, if you could part the announcement. Please dismiss football players today at 3:45. If you would please have them report to the cafeteria. Again,
all right, how do we solve for y? Divide by 3. So we got y squared equals 3. And then what do we do now? Square root. And anytime you square root to solve, what should you put in front of the square root sign? Plus minus. Okay, so that means we just found 2 y coordinates. So we know we're going to have 2 points. Nia, are you texting your mom so she knows that we have 2 points?
Yeah, that's my dad.
That's almost fair. Almost. Should have done that during lunch though, right? Yeah. All right. So we're going to have 2 points. One is going to have a positive root 3 and one is going to have a negative root 3 as the y coordinate. 2 points, right? And then what we can do to figure out what the x coordinates should be that go with those points is we can plug them in. And you could plug them in here if you want to die, or you could plug them in right here because that's nice and easy.
Oh, yeah.
Yeah. I say that because I'm not kidding. When I was writing out these notes, I literally started plugging them back in here. And I was like, this is the most terrible thing. I've got root 3s. This is the worst. And then I looked up here and I was like, oh my goodness. Miss Rice, you're terrible. As I call myself Miss Rice. All right, so we got 2 times root 3. So if I do the positive version, that gives me 2 root 3 for the x value. And if I do the negative version, then I have 2 times negative root 3, which would be -2 root 3. And so those are the 2 spots where we would have vertical tangent lines. Now, I would say let's graph it and check it, but that would be hard because the y is not isolated in this equation. Does anyone, do you guys use Desmos ever?
Yeah.
Do you know if Desmos, if you can plug the y's in? I think you can. You might be able to graph this sucker on Desmos and actually see those vertical tangent lines. Yeah. Like, how'd you guys do it? Yeah. That's good. Okay, you might not have liked the project, but Desmos is a really good way to check your work. All right, football players, bye. We like you. Bye-bye. All right. Okay. Are you guys ready? We're about to do a second derivative. Are you ready? Part C.
I want to be able to do lagging for a couple seconds.
Okay, so at the point 0, 3, find the rate of change in the slope of the curve with respect to x. Now they said, in here, they said rate of change in the slope. Rate of change in the slope. What is a slope? It's a derivative, but it's an instantaneous rate of change, right? So if they say find the rate of change of a rate of change, what does that mean? That's a second derivative, okay? So I'm going to say the slope is the first derivative, and that's the dy dx part. And then the rate of change in the slope is going to be the second derivative. And that is the part that I don't know how to pronounce. D squared y dx squared. I don't know if that's how they say it. I should look it up. Or let's nose goes. Who's going to look it up for me? It's between Erica and Leslie. It's Leslie. Leslie has to look it up for us. You have to look up how do we pronounce this, okay? That's your job. No, eventually. Because you lost nose goes.
Don't listen to notes.
Yeah, don't. No, you should listen to notes. Don't ignore the notes. Okay. Okay. We're gonna see. We can maybe do it. All right. So I'm gonna say my second derivative is going to be using. We have to go back and look at the first derivative we just solved. Where did my paper go? Oh, it's over here. So the first derivative that we just found was the negative 2x plus y over negative x plus 2y. That was our first derivative, right? So now with the second derivative, we have to find the derivative of that. Quotient rule, yeah. So we got low d high. And what's the derivative of the top? Negative 2 plus 1 dy dx minus high d low, so negative 2x plus y. And what's the derivative of the bottom? Dy dx divided by the bottom squared. Okay. So the nice part about this particular problem is they're asking us to plug in 0, 3. They're saying at the point 0, 3, tell us what the instantaneous rate of change of the instantaneous rate of change is. So that means we do not have to simplify this. Are you excited? No simplifying. What we have to do is plug in 0 for x and 3 for y. Does that make sense? Now plugging 0 in for x and 3 for y is going to get easy until you get to the dy dx and you're like, how do I plug in 0 and 3 for that? And the answer is we have to plug 0 and 3 for this. So we can see what dy dx equals, and then we can just plug it in right there. Does that make sense? Okay, so that's a terrible place to stop, but we're going to stop right there.